Sri Gurubhyo Namaha. Welcome to our online project Ekalaiva. Today we are going to discuss a very important lesson of 10th standard, carbon and its compounds. In this lesson we are going to learn about the carbon, elemental carbon you know very well. And now what are the uses of carbon, how they form compound, okay, and the compounds, what are the uses of the compounds, how to get the next series of that carbon derivative, all the things we are going to discuss in this lesson. What is carbon? Let us start from carbon, because we know carbon as an element, right? But what is meant by carbon and how it can form compounds, what type of bonding will be formed by carbon, all that thing we are going to discuss now. Now carbon, you know that it is an element, chemical element, but what type of element it is? We know that elements are of three types, isn't it? What are they? Metals, non-metals and metalloids. Right. In which category carbon will come? If you take carbon is a non-metal, because carbon can donate electron, if you ask me, no. Whether carbon can gain electron, if you ask me, no. It is a different element apart from the metals and non-metals, but we can take carbon as a non-metal. Why it can be taken as a non-metal? Because it will come under the category of the periodic table in P block, right? So if it is in P block, if you check, most of the elements are non-metals only, okay? So now carbon contains 4 electrons in its valence shell, okay, and it is belonging to 14th group, right, and it has 6 electrons and 6 protons and 6 neutrons, okay, and it is a non-metallic element which is available in the form of free state as well as in the combined state also. As it contains 4 electrons in the outermost shell, it cannot donate electrons or it cannot gain electrons. Only thing, mutually it can share the electrons with the other elements to form covalent compounds, okay? Right. So carbon as an element, how it plays a role as an element? If you take carbon, the atomic mass is 12. Which means that in nucleus it has 6 protons and 6 neutrons. So nucleus of the carbon atom contains 6 protons and 6 neutrons, so that the mass of carbon is 12, right? And the number of electrons, if you take, it is also same as proton, because you know that always for an element number of protons and number of electrons will be the same. So as it contains 6 number of protons, it has 6 electrons in the orbits, right? So if we write the electronic configuration of the electrons, we will be getting 2, 4, which shows that in K shell 2 electrons are there and in L shell 4 electrons are there. So if you draw the atomic structure of carbon, it shows that the nucleus of the atom contains 6 protons and 6 neutrons in the nucleus, and then there will be 2 orbits, and in that 2 orbits, the first orbit contains 2 electrons. Once we fill the electrons completely in the inner shell, then the other electron should be filled in the outer shell. Now what is the next shell? L shell is the next shell. K shell we have filled, because the accommodation of K shell is only 2 electrons. So after filling up the K shell, we have to come for the L shell, whose accommodation can be 8 electrons, but we have only 4 electrons, right? So those 4 electrons can be filled in L shell. Okay, now what is the valency of carbon? You all know very well, because already we have learnt in 9th standard about the valency. So as it has 4 electrons in the valence shell, the number of valence electron is also 4. We know that if the number of electrons are less than 4, those elements have the tendency to donate electrons. So they will come under the category metal. If they have more than 4 electrons, then those elements have the tendency to gain electron, is it not? So as they are gaining electron, they will be considered as non-metals. Now what do you think about carbon? It has only 4 electrons. Will it donate or will it gain electron? No, it cannot donate or it cannot gain electron, because if you look at the carbon atom, it is smaller in size and the nucleus contains only 6 protons, and those 6 protons can supply energy for only the 6 electrons in the orbit to held. Okay, so more than, if you think about that, just imagine if one more electron is added in carbon atom, just we are adding one more electron, okay, right. So if the electron has come here, now the accommodation of L shell will be 8, you know that, but so that there are more space, so you can add 4 more electrons, right, but to get that electron, definitely the proton should be more enough to give the energy, okay, the electrostatic energy should be equal, right. So the 6 protons can donate energy for only 6 electrons, not more than that. That is why carbon cannot gain, okay. And then let us come for the next thing. It has 4 electrons. Will it donate electron? Just imagine if it loses this electron, okay, loses the 4 electrons. If all the 4 electrons have gone, then what happened? This shell will not be existing, right, and only the inner shell alone will be there. So only 2 electrons are there in the inner shell and there are 6 protons inside the nucleus, and so the nucleus will have very high influence to attract the electrons present in the orbit, which is very closer to the nucleus. So the atom cannot exist. This is the reason why carbon cannot donate electron or gain electron. Then what, how the carbon can form compounds? If you ask me, I have an answer: only by mutually sharing, okay, only by mutually sharing its electron, that too valence electrons, okay children. So by sharing the electrons of carbon from the valence shell, it can form the covalent compounds. So that only carbon cannot form ionic compounds, but it can form covalent compounds by sharing the electrons of valence shell, okay. Now what are the uses where we can see carbon? We have carbon abundantly on the earth crust, whereas a little amount in the atmosphere. If you take atmosphere, in atmosphere we have 0.03% of carbon present in the form of oxide, that is carbon dioxide, okay. And then if you take the earth crust, it is more available, and then in the form of allotropes. If it is present in the form of free state, it is in the form of allotropes. In combined state, it is in the form of carbonates, hydrogen carbonates, fuels, etc. Occurrence, where it occurs. Carbon is found in the atmosphere as well as on the earth's crust also, right, and in all the living organisms. If you take our body itself is made up of carbon only, because we consume food and that food gives us nutrients and that nutrients build up our cells. So of course our body itself is made up of carbon and its compounds. And then where it present in the earth's crust in the form of fuels. Fuels in the sense wood, coal, charcoal, petroleum, fossil fuels, all that. Okay, and it is present in the earth crust as compounds also. What are the compounds? We can take calcium carbonate, magnesium carbonate. So carbon is present as compounds in the form of carbonates and hydrogen carbonates, for example, sodium hydrogen carbonate, magnesium hydrogen carbonate, lithium hydrogen carbonate, so on. Okay, and then it is found in the form of free state also. In free state, carbon is available as allotropes. Okay, in free state, carbon is available as allotropes. So there are three main allotropes, known allotropes of carbon. They are diamond, graphite and fullerene. Okay, so in Earth's crust, carbon is available in the form of allotropes as diamond, graphite and Buckminster fullerene. I'll tell you why it is called as Buckminster fullerene later. Now, carbon is available in free state as what? Allotropes we said. And the three main allotropes of carbon are diamond, graphite and then one more allotrope is fullerene. But among that, diamond and graphite are well known allotropes, but Buckminster fullerene, the study is going on still. Okay, the physical and chemical properties yet to study. Okay, that's why as it is not studied properly, we are taking only the diamond and graphite as allotropes of carbon, well-known allotropes of carbon, right? In combined state, carbon is available in air, that means in atmosphere as carbon dioxide. And then in the Earth's crust, it is available as fossil fuels, carbonates along with the metals, and then organic compounds, that means in living organisms like fat, protein, minerals, all that. Okay. Next, carbon are of two types, that means two forms of carbons are available. One is crystalline form and the other one is amorphous form. Crystalline form are like fine solids. Okay. They are free fall. We can say that they are free fall solids. For example, if you take sugar and salt, okay, they are like crystals, small crystals. So, carbon is available as crystalline form. If you take diamond, you can make any small shape of diamond. So, it is looking like a crystal, isn't it? So, smaller size. So, in crystalline form, again we have the three allotropes of carbon, that is diamond, graphite and Buckminster fullerene. And in the amorphous form, what is amorphous form? A fine powder. Fine powder. Okay, for example, talcum powder, tooth powder, if you take, okay, they are fine powder, right? So, likewise, carbon will be available as fine powder also. So, what are the fine powder forms of carbon? Coal. If you take coal, if you crush it, you will be getting a fine powder of coal. Lamp black. What is lamp black? It is nothing but when you burn lamp, you will see that the black color substance will be getting deposited. Okay, if you scratch out the substance and you take, it will be a black powdery substance. That is only called as lamp black. And coke, gas carbon, charcoal. These are all amorphous forms of carbon only. In charcoal, there are three types of charcoal we can have. Wood charcoal, sugar charcoal and bone charcoal, right? Okay, so these are the two different forms of carbon, that is crystalline form of carbon and amorphous form of carbon. And next one, a very important topic about carbon, and it is very interesting also to know about some facts of carbon, that is versatile nature. What does mean by the term versatile? It is nothing but all-rounder. We can say that all-rounder. If you take some of the elements like sodium, potassium, specifically they act as metals. If you take some of the elements like oxygen and nitrogen, specifically they show non-metallic characters. But carbon, as it cannot donate or gain electrons, it plays a number of roles in forming the compounds. Let us see that in next class, children. Thank you. To get more videos, please subscribe our channel to get latest updates. Thank you.